From toxic algae poisoning, drinking water, to storm of the century flooding events, climate change is already leaving its mark on the Great Lakes. But is the delicate balance of the region at a tipping point? Joining us now to examine what climate change is doing to the lakes and what can be done to stop it, Jennifer Day, Regional Coordinator for the Great Lakes Regional Collaboration Team. Sapna Sharma, Assistant Professor in the Department of Biology at York University, and Gail Kranzberg, Professor of Civil Engineering and Director of the DeFasco Center for Engineering and Public Policy at McMaster University in Hamilton. And as I welcome all of you around our table here at TVO, just a brief note off the top. My voice is not at its best. You may have heard there was a ball game in town last night, and I might have overdone it a little bit. Anyway, here we go. Sheldon, shall we bring up this footage? We want to start our discussion by showing footage in Tecumseh, Ontario. Last week, the town, along with Windsor, was soaked by 94 millimeters of rain in 2 days. That's the same amount of rain that the area usually gets for the entire month of September. The whole month in 2 days. Okay, Gail, Windsor and Tecumseh are situated on the Detroit River, which feeds into Lake Erie. With climate change and the Great Lakes, are we going to see more of this in the days ahead?
Highly likely. What we saw in Windsor, and the ramifications are amazing, but what we saw in Windsor is the kind of pattern that we're seeing with a changing climate in the Great Lakes region, which is periods of prolonged drought. You can think about this summer, with severe storm events, flash floods, soaking people's basements, backing up sewers into raw sewage going into their properties, massive flooding, for a few reasons. But think about the ground being so parched that it actually acts like concrete. So even if you had grassy areas that were completely dried up, you get a massive storm coming in because of the changing climate, and it just has nowhere to go but over the landscape. And in this case, it actually went also into the sewer system, and the sewage plant actually had to discharge part of its untreated sewage into the river. So you see
that doesn't sound good.
Well, that's, fecal coliforms, human waste, nutrients, all into the Detroit River for 5 days before they could get it under control.
Jennifer, follow up on that if you would. In what other ways is climate change having an impact on the Great Lakes?
Well, I think there are three main ways, at least the ones that I think we can talk about today. One is the timing and severity of storms, and more frequent storms. Another would be the warming of the surface water of the Great Lakes. And two, the decrease in ice cover is a serious issue.
How come?
Ice protects the lakes in a lot of different ways. It also prevents evaporation in the winter when most evaporation happens. And ice is also necessary for the ecosystem. For example, some cold water species need that ice to protect their eggs. And that can affect cold water species such as Great Lakes or lake trout.
Sapna, what would you add to that list of concerns?
I would also add water quality and water levels of the Great Lakes as two of huge problems that I foresee becoming issues in the Great Lakes under changing climates.
Gail, I want to pick up on the thing you mentioned about the storm sewers, because we had the former mayor of Toronto, David Miller, on the program to start off the week. He's now, of course, World Wildlife Fund Canada. And he talked about, when he was mayor of Toronto, before a lot of the infrastructure improvements were made, that when you got a heavy downpour, the storm sewers would overflow and all of that raw effluent goes right into Lake Ontario. Can you just explain for us, how do combined sewer overflows work?
Sure, and we see combined sewers typically in older municipalities, so former Mayor Miller would have been very, very familiar with this. You have water that is stormwater, and it goes into a pipe that is then connected to wastewater coming down from perhaps your toilets, your house, and all of that water is pushed into the sewage treatment plant, and all of it gets treated. However, if there's too much water coming through the storm sewers, there's an opportunity. It's engineered into the system that instead of destroying the functioning of the wastewater treatment plant, that extra water has to overflow somewhere. And that extra water then overflows. It's a mixture of sewage and stormwater, and it overflows straight into Lake Ontario in the case of Toronto.
And Jennifer, what does it do to the Great Lakes when all that raw effluent goes into the lakes?
Well, the way humans interact with our lakes, the lakes are enormous, but we really interact at that nearshore area. That is where we recreate, that's where we fish, that's where we go swimming. And when you get all of that raw sewage and runoff into the lakes, into that nearshore area, it really does have an impact on the ecology of the area. harmful algal blooms can be exacerbated by that and also affect our human health and beach health.
Well, I was going to get to that because, of course, that's our drinking water.
Yes.
Now, when raw human effluent goes into Lake Ontario, which becomes our drinking water, they can get all that out, can't they, by the time it gets back to the taps?
They can.
Okay. I think that's probably worth putting on the record.
Right.
But it's probably not a lot of fun doing that.
Right. I mean, the drinking water plants are well equipped to be able to treat raw water for our drinking and consumption purposes. But when you're out there, say, kayaking or going to the beach and wanting to swim, or even fishing, or doing any other types of sports where water's going to splash on you. I was thinking about Windsor. I was actually out sailing in the Detroit River during that storm. And the amount of trash that was left in the water after that storm passed and the amount of water that actually splashed up onto us, it always makes you wonder, what is the health impacts of that, especially when they've had sewage overflows.
I should ask you, what were you doing on the water knowing all that effluent was there?
I was in a sailboat race at the Windsor Yacht Club.
Oh, okay. All right. Gotcha. We're going to show a few more images here, okay? Sheldon, let's bring these up. Some photos from back in 2014 of an algae bloom that spread around part of Lake Erie, and it forced the city of Toledo in Ohio to issue a 2-day ban on drinking or cooking with tap water. This is the 21st century, folks. Look at this. Okay, Sapna, get us started here. What is toxic algae?
Well, toxic algae is actually it's a group of algae, cyanobacteria. And the one that was of concern in the Toledo case was actually formed through microcystis, which is kind of cyanobacteria that typically forms in the end of summer, in about August.
How does that happen?
Well, it's a natural occurring succession process with phytoplankton, and we normally see when the lake is stratified. So when we get layers within the lakes, you typically have cyanobacteria blooms.
So this happens, and it's natural, but is it a sort of an after effect of climate change, or is there a relationship to climate change there?
Well, the relationship to climate change is that we're experiencing more frequency of these toxic algal blooms, particularly when there's higher precipitation events and warmer temperatures. So they're leading to earlier blooms and more frequent blooms than we had seen in the past.
Does nature have its own way of getting rid of all this?
Yeah.
How does nature do it?
Winter.
Winter, oh, okay. All right. Okay, since it's not going to be winter for a little while,
Yeah.
how, if your water source is affected by a toxic algae outbreak, is that what you call it, or?
Algal bloom.
Algal bloom,
Yep.
okay. I mean, obviously, I presume you boil the water. Is it okay to drink after you boil the water?
No, not in this case, because microcystin actually is quite stable at really high temperatures, and so boiling the water just increases their concentration in the water, so you don't want to boil the water when you have a microcystin bloom.
So what do you do?
Drink bottled water, use bottled water.
But how do you get rid of it?
Well, there's
Before winter? If you
no,
can't wait for
there's
winter, what do you
treatment.
do?
There's treatment. There's treatment to get rid of these blue-green algae blooms.
And is it extremely hazardous to human health?
It can be very, it's called patotoxic, so it can damage your liver and you can experience nausea, dizziness, diarrhea, things like that from consuming water with microcystin.
I can already tell this is going to be a very pleasant program. Conversation has gone right into the toilet, pun intended. Jennifer, one of the things we've heard about during the course of the week is that one reason there's a lot of pollution in the Great Lakes is the overflow from agricultural use. Give us a sense about how successful the United States has been in curbing agricultural runoff into the Great Lakes.
I'm really glad you asked that because the United States is taking it very seriously, especially in the Great Lakes, and because of things like harmful algal blooms that have been affecting Lake Erie. And several different governmental departments in the U.S. are responsible for work within the farm runoff area. And so we've been working directly with farmers. We've had different science agencies that have been working with monitoring near field and off field sites to see how much is actually running off, how effective are our berms that are to try to prevent a lot of that runoff from going into the rivers. My own agency just started a new program that's also getting funded from the Great Lakes Restoration Initiative, which is a U.S. Initiative. They've been putting millions into this issue on all fronts of the runoff. And we now have a rapid runoff risk assessment forecast that we are providing to farmers across the U.S. states that can give them a 7-day forecast from their phones that tell them what is the best day based on meteorological data to apply fertilizer, apply manure onto their fields to reduce the amount of runoff or prevent that amount of runoff.
Can you tell if they are changing their habits or their practices?
I think it might still be too early to tell. I think we've had a lot of success in the areas that we've really been focusing on, like very small micro areas where we know the worst offenders are. So we're starting there. And, we'll be doing more monitoring. We have money to do monitoring, and then that will be able to tell us if we're being effective or not, and if we're being effective in the right areas.
Gail, how about agricultural runoff in Canada? How are we doing?
Well, we don't have anything quite like the Great Lakes Restoration Initiative in Canada. Our federal investment in Great Lakes is a few orders of magnitude less, unfortunately. So I think we're on our way. Just yesterday, the province of Ontario convened the Great Lakes Guardians Council, and membership there now includes those where there could be a priority for action on Lake Erie, which is really the one suffering the most from the agricultural runoff of phosphorus. And at that table is the agricultural institutions, are the agricultural industries. And this is a great breakthrough because up until now it's been a tension. This is the traditional way that we've always farmed, or this is the way we're going to continue to farm. And now they're at the table understanding that they need to be part of the solution because Lake Erie's catastrophic changes are going to get, you said exacerbated, going to get exacerbated under climate change, and the more agricultural runoff we get, the worse it's going to get. We don't have the funds and the sophistication yet that we just heard Jennifer talk about, but I'm optimistic that we will start to see new progress now with those presence at the table and that willingness to have that conversation.
A couple of follow-ups there. Are you confident that agriculture understands that it has to change its past practices because of the new realities we're talking about tonight?
I'm confident that there are industrial associations representing agriculture that believe that.
So that suggests to me that the farmers aren't there yet, but maybe the people who represent them are?
Or a blend.
Or
the
a
people
blend.
who represent them, I believe, are. I don't believe I could speak for all farmers, but clearly there are those who are looking with modern perspectives, and there will always be those that have done things a certain way and always want to do in that certain way. I couldn't tell you what the percentage split there is. But at least if the associations are moving in that direction, then the perhaps more recalcitrant farmers may see the light and come on board.
And one more follow-up. Again, one of the things we've learned this week is that Canada often talks a good game on environmental issues, and we like to think of ourselves as being a very environmental nation, but oftentimes we're more sanctimonious than effective, and in fact the Americans are ahead of us on a lot of stuff. Why is that?
That's a very difficult question to answer, and I think we've seen variations in that over time. If you look at the past 10 years, for example, you may see it relating to the political leadership in our country and what their priorities happen to be. I want to be cautiously optimistic that the political leadership now, who have been there and acknowledge globally that climate change is human-induced. I mean, our Prime Minister has said that. I don't think we would have seen that from our previous Prime Minister. Unlikely, perhaps. But I think there's a change in understanding what Canada really is and where Canada should be a leader. And I think we are having to catch up now with the United States. And it's not a bad thing. At least we're catching up with the United States.
Sapna, let me follow up with you on the issue of the fisheries. What kind of impact is climate change having on fish life in the Great Lakes?
Well, actually, so Jennifer talked about increased surface water temperatures and increased water temperatures in general. And what that's leading to is an increase in the spread and distribution of warm water fishes, some of which are invasive, like the smallmouth bass, and also a decrease in cool water fishes and cold water fish habitat, as well as their distribution, such as walleye or pickerel, you might have known them as, or lake trout. And so we're seeing the spread of these invasive warm water fishes throughout Ontario moving northwards.
This is the smallmouth bass, for example?
The bass,
Why is
yeah.
that a problem if it's more proliferating?
It's a problem because they're such voracious predators. So they consume a lot of the minnows. They consume the fish that the walleye and lake trout eat, and they also so they compete with them, but they also predate on their young, and so that's declining our native cool water and cold water fisheries that are important to our Canadian identity.
So we don't like the smallmouth bass.
No, we don't.
Interesting.
And a lot of bass are being spread by humans, and so curtailing the invasion of bass throughout Canada, not just in Ontario, is an important way to protect our fishery.
Okay. Let me put a huge issue on the table right now, because obviously we're at a point in our history where people are debating, what do we do now? Do we try to reverse the effects of climate change and hope that we can make progress in turning things back? Or we are where we are, and we're just going to have to learn how to adapt to all of these realities that we now seem to be faced with? Let's go around the horn on that, please.
Well, I think there's a place for both. The idea of mitigation, where you're trying to do things like burn less fossil fuels in order to curb climate change. But also, I think adaptation is incredibly important, because adaptation is what you do regardless of what's causing climate change. It's occurring, and we know it's occurring. So what do you do, regardless if it's going to be very severe or even moderate in the future, to protect ourselves and become more resilient to what the climate's actually doing?
Your thoughts, Gail?
I agree with Jennifer. Mitigation of greenhouse gas emissions within the Great Lakes region itself is not going to help the Great Lakes region. It has to be a much larger initiative. That's not to say we shouldn't be doing it, but it's very true that these floods that we're seeing, the spread of bass that we don't want, these various activities that are affecting us, even the crops that we can grow under a different climate. These are very real things that we need to start recognizing, and our predictions, we can start doing them now. We can stop combined sewer overflows. If we know that they're going to be increasing in frequency, we can engineer infrastructure differently now and have no regrets, even if it's not as severe as we thought, because population is going to grow anyway. We're going to need the infrastructure. There's many things that we need to be doing now, because to ignore the fact that climate change is real means that the insults to the region and to human health and property will just continue to increase.
Mitigation versus adaptation, where are you?
I think both needs to happen, obviously, but I also think we need to accept the fact that climate is already changing quite a bit in this region. So one of our recent studies that we did, we looked at water temperatures around the world and how they've changed in the last 25 years. Lake Superior was the second fastest warming lake in the world, and in a 25-year period has increased by over 3 degrees Celsius. And the Great Lakes on average have warmed by 1.5 degrees Celsius in the last 25 years. And so just thinking about how ice has changed, how water temperatures have changed, how water quality has already changed, I think that should bring the impetus to, we really have to act now. It's not something about the future. We know that it could get worse, but we have to realize that it's already changing.
Jennifer, when you talk about improving infrastructure to help with climate change on the Great Lakes, what are you thinking of?
So to give you a great example, as we talked about earlier, combined sewer systems, some of our older communities need to separate those sewer systems. That is a multi-million-dollar prospect. So what some communities are doing, they're looking at, putting out this huge outlay of public funds, and they can look, they want to know what's happening, what are the predicted rainfall amounts or the severity of storms that will be happening even 25 years from now, so that they can actually plan the size of the sewer system that they're going to install that can accommodate future increased extreme rain events, so that they can protect their infrastructure and protect their communities.
Is there a way to think of stormwater as an asset rather than a problem? Not really, eh?
I think there's a lot of issues with stormwater, but I think it does need to be, addressed. I mean, I think from at least a life and property type of issue, that when you do get severe storms, you get flooding, you get community flooding, you are risking lives, you are risking property. And so how do we look into the future and be able to accommodate the kind of predictions that we're seeing for extreme storms, and be able to create our infrastructure in a way that's going to deal with it better than we're doing now.
Gail, you want to follow on that? Stormwater as an asset?
Stormwater as an asset. A few of my colleagues and me have done some research on this, and it is a vacuum. Stormwater absolutely is an asset. It's seen as something that we need to pass through our communities as fast as possible. After Hurricane Hazel, 1954, where people were, 80-something people lost their lives in Toronto alone for living in the floodplain. Get rid of stormwater. It's a nuisance. It's a bad thing. If we can capture stormwater and use it for irrigation, use it for toilet water, use it for all sorts of different applications, and get it as something that is something useful to us, capture it, store it, so when you have droughts, you now have stormwater that is stored. It's now an asset. You could use it for municipal purposes or for personal property purposes. Our municipalities understand what their assets are when it comes to wastewater plants. They know what their assets are when it comes to drinking water plants and what they're going to need to invest. They have no idea what their assets are or what even their stormwater capacity is. It's just not been part of the equation. And now, with the climate change conversation that we're having today, for example, it's an absolute imperative that there's new ways of looking at stormwater as something that is not just get rid of it, it's capture it, reuse it for beneficial purposes.
You're the engineer, I'm not, so I'm having a hard time right now imagining how you would begin to store that kind of water. How would you do it?
In a situation like the Windsor flood, you couldn't, because those are extreme events. But there are many other times where we have storm events where you can capture it in cisterns, in detention ponds, even in a property owner can capture it off their roof into their rain barrel, get it out of this stormwater system. So it could be done at a property value, at a property level, but it can be done at a municipal level where you have detention ponds, detention facilities, call them what you want, but you can imagine like a big underground storage tank where the stormwater goes and it sits. And when you can then are ready to use it, then you can pump it out and make it available.
Okay, let's put one more issue on the table here. I am reliably advised by one of the people running for president in the United States that climate change is a hoax perpetrated by the Chinese to make your country less competitive. Mm-hmm. Right? We all agree on that, right? No, maybe not. Okay, we don't agree on that. But one of the things I do want to put to you, Sapna, let's try this. We have been hearing for years, and I've seen it as well, got a cottage on Lake Huron, year after year after year after year, the water levels have been going down, probably for 20 straight years.
Yep.
And then all of a sudden, the past couple of years, the water levels are up, quite a bit actually. And people are saying, first of all, we thought you were stealing our water. We thought you Americans were stealing the water, which is why the levels were going low. And now no one can explain why the water levels are going up. Here's the question. How difficult, because of how varied this is it to predict what the actual impact of climate change will be?
It's very difficult because I predict the effects of climate change on biology, lake water temperatures, ice, fish. And the problem is that it's a wicked problem. There's just so many different factors that are coming into play. Temperature, clouds, solar radiation, precipitation. But then at the biological level, species interact with one another as well, and that changes things. In addition, so it's a really complicated problem to understand, and predicting climate change can be really complicated. But the great thing about our models now is that we have a ton of different scenarios that predict. We have a range of uncertainty. And so by incorporating this range of uncertainty into our models, we get an idea of what things may be like at a certain extent. So we can't say it's going to be exactly like this, but we can give you a range of variability or a range of uncertainty.
Okay, in that range, can you say that the reason the water levels in the Great Lakes have gone down so significantly over the past decade has something to do with climate change?
Yeah, we can develop models to look at what the drivers are of for example, water levels. And what we're finding is that increased temperatures, changing precipitation patterns, and also these large-scale climate drivers like the El Nino Southern Oscillation or North Atlantic Oscillation are all contributing to changing water levels.
In our last couple of minutes here, I was joking about Trump. It's not a funny matter, but the fact is, politics gets in the way of science a lot. How much in your experience?
It depends on how the scientist speaks to the politician. So if a scientist understands that you have two things, you have a policymaker and then you have a politician. If a scientist can explain the science to a policymaker in a language that the policymaker is looking for, what is the economic consequence of your science? What is the social and cultural consequence of your science? Not just what is the science piece, what is the environmental piece of your science. Then you need to understand that that policymaker still needs to pass it on to a politician. But if they are versed in language that the politician then is familiar with, then you can have that transition go quite well. What does happen, though, is votes. So if you're trying to get a politician to do something that is scientifically sound, engineering sound, and the policymaker understands it, but the public at large doesn't and will rally against it, then the politics can get in the way of science. And the politician will go for what the public's expectations are and develop a policy that is reactive rather than science-based. In Canada, though, we've heard it from very recently that our policies are going to be science-based. They're going to be evidence-based.
That's what they're saying.
And that's what they're saying, so that's what we better watch for.
Gotcha.
Who knows if it's going to be.
I want to thank all of you for coming, Mr. Director. How about a nice wide shot so I can say goodbye to all of our guests for coming on TVO tonight. Thanks so much for your help on this.
Thank you.
Help TVO create a better world through the power of learning. Visit TVO.org and make a tax-deductible donation today.